Okay, so the next step for us here, we have built out our loop, kind of our loop here. We're just going through, we're taking the readings, we're setting the servo. So the next step is to now kind of go through here and do some kind of control to output based on the current value and the set point, what position we want the servo to go to. And so for now, we're going to comment out this line here where we read sensor 2. And we're just going to kind of ignore sensor 2 for now until we have our basic functionality working. And what we'll do is we'll say float set point equals, and then let's actually come up here and we'll add just a pound define. And then let's say our set point would be, and you can just adjust this however, we'll start with 15.0 centimeters. Okay, and then again, we could, as it's going, you can adjust that how you want it to be. And let's do, what do we call it? Oh, sorry. Set point, there we go. Pound defined, set point is 15. We'll put that right there. Okay, and so now we're going to pass those into our function here. And so what we're going to find, let's calculate the difference. So we'll say difference equals current value minus set point. So see how far we are from the set point. And this will also tell us which direction we're away, if we're too close or too far based on the sign here. And then we will do a int servo equals, and then we have the map function. Okay, so when we do this, this is not going to be great because the map function is working with integers, so it's going to actually round these value, the difference to the nearest centimeter, which will actually be okay right now. We're not going to worry about that. But so we're going to take our difference, and let me find the prototype for the map function. We're going to say Arduino map function. Okay, so we pulled up in the reference here, and then, okay, we'll paste these in as a reference. So it says the first one we start with the value, then from low, and then from high. So we'll say the difference could be all the way down at negative 15. All the way up to positive 15, and you can adjust these later. And then the too low and the too high would be somewhere between 0 and 180 for the servo position. Now, you might end up deciding that this is not a great solution here, and we'll talk about why. But so we might not have the same amount of control on either side of the central point. 90 might not be the center. This will map the position of 90 to the center. And it will also then we don't have a way to account for what happens when it goes outside, and we can't write the servo less than 0 or less than more than 180, and so that'll be an issue too. However, this is a starting point. We can also switch these to be positive 15 here and negative 15 here in case we have it like backwards. And so this will be things that we can adjust depending how we want to do it. And we'll call this servo position, and let's go ahead and return that. And now we're going to, we have our same function. Now it's going to write that servo to that new servo position. This function's wrong. It should be servo pin, comma, servo position. Okay, and so let's go ahead and test this function in the simulation and see how we do. Or this. Okay, some mistakes that we have here that I just caught. So the right function should just be the position. So I was passing in the pin before, and then I passed an argument, but we just passed in the position. And then here we have to declare this as a variable. We'll call it a float. Okay, and so that's good. And then something else I ran into is that, so I've been able to use these sensors at a pretty close range, but the simulation doesn't allow for it. And so I'm going to in here change those values to be pretty big so that our simulation works. Okay, so as I mentioned, I might have modified some of these set points, and so as you're messing with it, you can change them for yourself. So I changed this to be 100 just because of the range that it provides here. And so I changed the endpoints here as well. Those are things to mess around with. But now, when I move this, we can see that the servo, if we zoom in a little bit, the servo moves as I change this. And so this is kind of what we want. So we're tilting our ramp depending on how far the object is away. Now when we actually test this with an object, this is our proportional control. So we're based on how far away the object is, we're changing the angle of our ramp. And so this gives us an oscillating set point, which is a good starting point, but we need to get past this and to the point where we can also account for the velocity and the accumulative error that the object has. But this is a good stopping point here, and then next step will be to add in we'll start to build out an actual PID controller. So we'll go ahead and change our approach, and we won't be using the map function anymore.